All right, so I tried to give you a couple of study tips for, and today I want to talk a little bit about chapter 9, the sort of thing that I would tend to do if I found myself in your position, to just help me recall the things we were doing when we were talking about sequences and series. But before I do that, I will say the exam is actually on Canvas, okay? But it's the same kind of deal as before. Study up, kind of get yourself ready, and just plan on having like a couple hour block of time in place to sit down and take the test. I wrote it so that it would probably take around like an hour or something. So you should be able to bank on that basically. There are a few helps at the end. There's the series convergence table, and I did not put this in there, sort of the power series for elementary functions. This is at the end of chapter 9. I'd rather you kind of familiarize yourself with that, especially e to the x, sine of x, cosine of x, and then like 1 over 1 plus x. The logarithm one's also useful, although they give a different version than the one that we gave in class. Basically, the version that they give here, what we did is we replaced x, so x is going to get replaced by 1 plus x, okay? So that we had logarithm of 1 plus x. And that's, of course, going to change the interval of convergence as well. But I would just familiarize yourself with the geometric. The geometric isn't even on here, like 1 over 1 minus x. The reason I didn't put this on the test is I don't know that it's exactly the most helpful table. 1 plus x squared plus etc. Okay, but that was on the last exam. So you should be pretty comfortable with some of that. So this replacement of x by 1 plus x, that's for this series right here for logarithm of x. So you should set aside a couple of hours. Everything that you need should be right there on the test. Okay, so you're sort of on your honor in that regard. That thing is due on Wednesday of next week at noon. So try to upload that thing, or you can just turn it in by hand if that's more convenient for you. Okay, but it's there. So you basically control that at this point. Okay, any questions on that? Questions? Yeah, Drake. Yeah. I put my office on there as well. In case you didn't know that already, it's like ENS 371. So you can come turn it in there if you want. Other questions? There is one problem where I allow you to utilize GeoGebra, and I give you an actual URL link in the PDF document. But that's the only thing that, the only problem I am going to let you utilize that, okay? It's the last problem. You shouldn't have to, for instance, I think there's probably some other problems where I ask you about quadric surfaces, but I give you the sheets in the exam that kind of delineate the basic quadric surfaces. But you're supposed to graph that straight out of your mind, just based on the sheets that are given to you at the back of the exam, okay?
So like we have to actually draw quadric surfaces?
Yeah, I want you to draw it. Yeah. It's cool.
Okay.
It'll be a good time.
Like how accurate are you expecting these drawings?
Well, I mean, I want the drawing to at least be recognizable, I guess.
Like the right type.
And I want it to be the correct orientation, for instance, you know what I mean?
Okay, so I pointed on the right axis.
Yeah, that's right. So like oriented about the correct axes.
Okay, but you're not going to be too precise
It's like, oh,
expansion.
right. So, right, I'm not going to try to find a point on the surface that's like, oh, this should have been the square root of 3, and clearly you're like too close to 2 for it to be the square root of 3 or something, right? I'm not going to be that precise, but I at the very least want to see you exhibit that you know stuff about orientation of these quadric surfaces. Does that make sense? Some of them are easier to draw than others, but it's good practice learning how to draw things. Well, you know what? I was kind of telling my last class about this. I've been reading Moby Dick to my kids. And we like go through all of these classic novels, right? And Moby Dick's like massive. Do you realize this? I mean, it's like 700 pages long. But probably about 400 of those pages are, it's basically a whaling log of like how to be a whaler, like in the early 19th century. Does that make sense? So it's basically like a how do we actually harvest said whale? Where is it? I mean, I've learned all this stuff about sperm whales that I never thought I would know. It's sort of amazing, actually. But well, like 10, you know, some of it is fairly, it kind of, man, I don't even know how to describe this. This is just what happens with classic literature sometimes. Like, it should be really boring, but it's like strangely intriguing, like reading about how they would harvest these whales. You know what I'm saying? It's like, wow, I never would have thought of that. Who thinks to cut open a whale's head and actually go down inside of it as a full-grown human being and try to harvest stuff? You know what I mean? It's like amazing, and it's like super detailed. But one thing, the reason I bring this up, the one reason I bring this up is the following. Everybody back then knew how to write well and describe things in full detail, but they also knew how to draw stuff. Not just artists, you know what I'm saying? But everybody knew how to draw stuff and give sort of dimensionality to things and kind of make sense. I mean, there's all these sketches in there, and I'm like, Herman Melville? What in the world? How did he know how to draw like this? It's just sort of amazing, you know? But I was thinking about it, and I'm like, man, that used to just be a skill that everybody had. They all had really good handwriting. They all could write really well, and they all could draw really well. Like everybody knew how to draw, and the artists were like actual artists. You know what I'm saying? Like they were just way better than everybody else. Yeah, yeah, that's right. So I don't know. All that to say, you should go read Moby Dick. It's fairly amazing. Moby Dick? Moby Dick is classic literature. Yeah. Yeah, I mean, to be honest with you, I'm not reading through all of those details. I read through it though. I mean, it's fairly amazing, but I did read the parts where they were, because there are some things that happen, like when they're harvesting a particular whale, that are pretty exciting, you know. But and in order to like make sense of that, I had to go read the parts about that. But no, we're actually, well, we read Treasure Island. That was hard. That was hard for me to read because there's like tons of pirate language. And I'm like, I don't even know what these guys are saying right now. And I just straight read it in like a gruff voice. And somehow the kids all like understand what's going on. I'm like, what? How do you even know what that means? I don't even know what I just read, but they get it. So you'd be surprised what kids can understand. It's fairly remarkable. So that's why I want you to draw some quadric surfaces. Yeah. All right. So I don't know that I need to go all the way back to the beginning of Infinite Series. Man, what's going on with this thing? It seems like giant. But one thing I would suggest is if you go to the section on power series, do you know what I'm saying? That's where you really start to understand if you know what you're doing, okay? Basically, power series, in some sense, reveal the chinks in the armor, if you will, okay? So that said, I want to go to the review exercises, and we'll look at some of these. Let me see here. This is like, what is happening here? 100%. Okay. So for instance, let's see. You guys remember the formula for geometric series? Hopefully. So you could actually find the sum of some of these series, okay? But I want to look at some of the power series problems, and the ones that I think are really helpful in terms of series convergence are the ones that don't tell you what to do. I mean, for crying out loud, look at this one. It says, use the integral or P series test, right? Well, of course, that's what you're going to use. You know what I'm saying? But most of the time, you're not going to have the luxury of knowing what test to apply. So I think there were some here where they just said, fine, where were they? I lost them. Hang on a sec. Alternating series, are you serious? They just tell you what to do on every single one of these? Is that what they're going to do? I thought I saw one in here where it didn't tell you what to do. Well, anyways, let's just kind of talk about this for a minute. So look at like number 52 right here. Okay. What do you think about that? Does that converge or diverge? Diverge? Why does it diverge? No, that's not a valid reason. If the bottom gets larger faster, the terms go to zero. That doesn't tell you. Diddly squat. Okay, if the terms go to zero, that just means there's a chance you might have convergence. If the terms don't go to zero, and the term test says you have a diverging series. But what about that? What about those terms? Yeah, Michael.
I think you use like either direct comparison or limit comparison test to say that this would diverge because it's going to be basically 1 over n.
Yes, because like n plus 1 over n plus 2, I mean, let's just be honest, that's basically like 1, right? For n large. So that means that these terms behave like 1 over n, yeah? So in some sense, you know, this series is going to behave just like the sum 1 over n, which you know happens to be a diverging series, yeah? Okay. What about like this? What about 51 right here? What do you guys think about that? What do you think that's going to behave like? That's n to the power 3. So that thing is going to behave like the series 1 over n to the 3 halves, which what does that series do? Converges, right? So this guy diverges over here. This guy converges, okay? So limit comparison kind of puts those ones down pretty quickly. What about this one right here? What about 54? What do you guys think about that? I think the -5 matters a lot. Not as far as convergence and divergence is concerned. So what do you think this one's going to behave like? Series what? One over 3 to the n, which does what? Yeah, that converges, right? That's a geometric series, okay? Okay, so that's the sort of thing. What do you think you would do on 53? I mean, forget about the fact. I mean, I don't know what they're thinking, saying to use direct comparison or limit comparison. Like 53 is a product of a bunch of things, yes? What test do you think is probably going to be most beneficial in that case? Ratio. Yeah, ratio will do the trick. Yeah, that's right. Okay. All right. I want to go down here and look at some power series. Again, power series tend to reveal the chinks in the armor, so to speak. Oh man, I think I see the ones I was, yes, they're down here. Let's do those ones first. Oh man, it says find the sum of the series. Are you serious? Wow. Okay. Well, here's something. E to the x, you know that e to the x is like 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus etc. Right? That's like and the radius of convergence for that was infinity. I mean, this thing converges for all x. So that's the Maclaurin series for e to the x. Now, look at this series right here, number 92. How would you do that one? Which, by the way, you guys realize that this is sum in going from 0 to infinity of x to the n over n factorial, right? Okay. N going from 0 to infinity, x to the n over n factorial. So, I mean, there's a reason I'm kind of cherry picking the exponential Maclaurin series. Okay. How would you determine this sum right here? Yeah, that's right. X is 2/3. So this is like e to the 2/3. How weird is that? Yeah. So the more terms I add on there, the closer I'm going to get to e to the 2/3. This is how computers approximate these things. Does that make sense? And power series are incredibly useful. Okay. So that wasn't exactly what I was hoping for. I thought that this was the list of series where they didn't tell us what to do. Okay, but maybe that's down here somewhere. Nope. Okay. So let's go up here and look at some power series. Okay, so for instance, what about number 78? Okay. 3 to the n, x minus 2 to the n. So first of all, this is a power series centered where? At 2, right? Everything is centered at 2. The best approximations are going to be close to x equal to 2. But we're going to get convergence in a radius, in an interval, where 2 is at the center and the radius is the distance out to the edge from the center, the edge of that interval. So let's see here. What would I do to figure out the interval of convergence? Which, by the way, finding the interval of convergence automatically means that you should check for convergence at the endpoints, okay? Finding the interval of convergence means that you don't just find the radius, but you also check what's happening at the endpoints themselves, okay? What tests do we always use for power series? Or did it seem like we always used the root or the ratio test? Yeah, the root or the ratio test. And you take the absolute value, right, of the term, and then you either take the n plus first term in absolute value over the nth term for the ratio case, or you do the nth root of the terms, and you take the limit as n goes to infinity. Yeah? In this case, an is equal to 3 to the n times x minus 2 to the n over n. Yeah? What do you want to do, ratio or root? Root? Okay. So if I take the nth root of the absolute value of an, That's going to be nice. Like the 3 to the n, that's just going to be what? 3. I take the nth root of x minus 2 in absolute value. That's just going to be absolute value of x minus 2 over the nth root of n, which I'll just write as n to the 1 over n. And what does that go to as n goes to infinity? As n goes to n to the 1 over n, what happens to n to the 1 over n as n goes to infinity? 1. It goes to 1. Okay? So this whole thing is going to go to 3 times the quantity absolute value of x minus 2. And to have convergence, I need this to be what? Less than 1. And therefore, we know that we need to have x minus 2 an absolute value less than a third. See what I mean? Yeah? Okay. And that means that x minus 2 itself is between 1/3 and negative 1/3. Don't you see? Yeah? Which means that x, excuse me, is between where and where? Yeah, x is between 2 1/3, which is 7/3, and bigger than, okay, so it's going to be 2 minus 1/3, which is 5/3. Don't you see that 2 is right in the middle of that? Yeah? 6/3 is equal to 2. Okay? So the radius of convergence, think about it for a second. It's 2/3 across the whole interval. So the radius of convergence is what? What's the radius of convergence? Yeah, the radius of convergence is 1/3. Okay? But I also need to figure out what's happening at the endpoints here to get the interval of convergence. Like what's going on at 7/3. And by the way, you guys know that 7/3, that's the same thing as 2 1/3, right? That might be convenient later on. And you guys realize that 5/3 is the same thing as 2 minus 1/3. That might be convenient later on, yeah? So what happens when I plug those things into the series? What happens when I plug those things into the series? Like if I plug in, let me just write this in here. Like if I plug in for x, if I plug in 2 1/3, what is the series? So if I plug in x equal to 2 1/3, what is the series that I end up getting? It's going to be sum 3 to the n times, think about it, it's going to be 2 1/3 minus 2, which is just 1/3 to the n, right? So that's 3 to the n times 1 over 3 to the n over n. Hey, what do I end up getting? 1 over n. And what's true about that? This diverges. Okay, so it diverges, right? So it diverges up here. So it diverges at that endpoint, right? Make sense? What if I plug in 5/3? What if I plug in 5/3? Okay. No, let's see here. How do things change? How do things change? If I plug in 2 minus 1/3, instead of 3 to the n times 1/3 to the n, what's it going to be? Negative 1/3 to the n, and this is all over n. So what are we going to get here? The 3 to the n's cancel, but I still have a minus 1 to the n. You know what I'm saying? So it's going to be sum minus 1 to the n over n. And what's true about that series? So in the end, if I plug in that value of x, I get sum minus 1 to the n over n. That's the alternating harmonic series. And what's true about that? That thing converges. Okay, so at the left endpoint, At the left endpoint, I actually have a converging series. Okay, so what is the interval of convergence in the end? Bracket 5/3, 7/3, open. Yeah? And of course, the radius of convergence here is 1/3. Okay? And incidentally, did I have to use the root test there? No. If I would have used the ratio test, I would have come to the same conclusion for sure. Okay? Okay, so our radius of convergence is 1/3. The interval of convergence is given by that right there. We had to check the endpoints to sort everything out on that one. Okay? Any questions on that? Again, my admonition to you is to really practice some of these, power series problems, because they kind of test your mettle and make sure that you really know what you're doing. Even when you check the endpoints, you have to draw on stuff that you knew. Like we just now we were like, oh, harmonic series, I know what that does. Oh, alternating harmonic series, I know what that does. Yeah. So even when you're checking the endpoints, even though we exclusively apply the ratio and root test at the beginning, you have to remember other things as you're kind of tidying things up at the endpoints of these intervals. Okay, so that's a good thing for sure. Okay. Any questions on that one? Let's see, let's do another one here. Hey, what about number 91? What's that going to be equal to? E to the what? Yeah, that's the square root of E. Looks like you plugged 1/2 into that thing. That's exactly right. Do you guys remember? What logarithm of 1 plus x equaled? Do you guys remember that? It was like x minus x squared over 2 plus x cubed over 3 minus etc. Where did that come from? Well, it came from this. If you integrate 1 over 1 plus x dx, yeah? You know what 1 over 1 plus x is as a power series, right? That's the integral of 1 minus x plus x squared minus x cubed plus etc. dx. And of course, if I integrate 1, I just get x. If I integrate x, I get x squared over 2, etc. But of course, what's the antiderivative of 1 over 1 plus x, for crying out loud? It's logarithm of 1 plus x. Do you know what I'm saying? Yeah? And by the way, you might say, shouldn't you have a plus c in here? And that's true, but actually if you plug x equal to 0 in, you should get 0. So the constant actually goes away, okay? So this is the power series for logarithm of 1 plus x. Okay, it turns out the interval of convergence for this thing, if I plug in 1, I get the alternating harmonic series. If I plug in -1, I get the negative harmonic series. So -1 I can't plug in, but 1 I can, okay? That's the interval of convergence. The radius of convergence is 1. Why do I show you that one? Well, because you think about it for a minute. I plug this in. This is sum n going from 1 to infinity. If I write it in summation notation, this is sum n going from 1 to infinity minus 1 to the n plus 1 over nx to the n, which looks a lot like some of these, doesn't it? Yeah? What does it look like I've plugged in to, so look at this one right here. What does it look like I've plugged into the logarithm 1 plus x formula to get that series right there? Sum n going from 1 to infinity minus 1 to the n plus 1, 1 over n, 4 to the n. What does it look like I plugged in for x? What do you guys think? Isn't it just a fourth? Didn't I just plug in a fourth? Because it's like 1/4 to the n over n, yeah? So what this is going to be the same thing as logarithm of 1 plus a fourth. I'm allowed to plug in a fourth, right? What about this guy right here? That's logarithm of 1 plus a fifth. And I'm allowed to plug that in as well. Okay, so that's kind of interesting to have to recall some of those things, yeah? And on the last test, you had to remember, or you at least had to be vaguely familiar with the relationship between the logarithm and the geometric, okay? Any questions on that? Okay, so let's go up here. Maybe let me see what's down here. No, that's no good. There was one on here I was wanting to look at. Right, so like what about the interval of convergence for what about the interval of convergence for this guy right here? Okay. Well, here we have an equal to minus 1 to the n, x minus 2 to the n over n plus 1 squared. Okay. What do you think is going to be most useful? Ratio or root or what? All right, let's do root. So we take the absolute value of an, and we take the nth root of that. Now, when I take absolute values, does that alternation really matter? No. The alternation does not matter. Okay. So, let's see here. So we're doing this one right here. So this is going to be the nth root absolute value of x minus 2 to the n, which is just the absolute value of x minus 2 over n plus 1 squared, 1 over n. So this is going to be n plus 1 to the 2 over n when I take the nth root. And what does that go to as n goes to infinity? What does n plus 1 to the 2 over n go to? What do you think that's going to go to 1? Okay. So if that goes to 1, the top just stays where it is. It's just x minus 2, yeah? Absolute value. And what do I need to be true about that to have convergence? It needs to be less than 1, which means x minus 2 is between 1 and minus 1, which means x is somewhere between where and where? I would just add 2 to everything and get that x is between 3 and 1, yeah? Now, that means that the radius of convergence is 1, okay? But I want the interval of convergence, which means I need to ask the question, what is happening at these endpoints, 1 and 3, yeah? So what is happening at those endpoints? Well, if I plug in 1, Okay, so let's see here. What happens if I plug in 1? If I plug in x equal to 1,
We take like a step back and check out. So how did we find that it was between? How did we go from where we were to finding the radius in this instance? Because I got kind of lost.
well, but the radius you could have gotten back here.
Yeah. But so how did we go from absolute value of x minus 2 over 1 to finding that it was between 1 and 3?
Okay, if something in absolute value is less than 1, that means it's trapped between -1 and 1, correct?
Did we know that it was?
I mean, that's just, well, to have convergence, right? So to guarantee convergence, the limit, which is what we just computed, needs to be smaller than 1.
Okay.
If the limit was bigger than 1, it would diverge.
Yeah, that was what I was.
Okay. That's why I wrote it in blue, because it's like we need that limit to be smaller than 1 to guarantee what? Convergence. Okay.
Because it's still a sum.
Yes. Yeah. Okay, so if you plug in x equal to 1, what do you get for the sum? It's going to be sum minus 1 to the n times minus 1 to the n, but that's just minus 1 to the 2n, right? Over n plus 1 squared. But minus 1 to the 2n, seriously, that's like 1, yeah? That's like taking minus 1 and raising it to an even power. So this sum would be sum 1 over quantity n plus 1 squared. And what's true about that? It converges. It's like a p-series, yeah? This thing converges. Okay? So that means over here that I am allowed to plug in 1. So I can actually plug in 1. Now, what about 3? All right, so I can plug in 1. Now, what about 3? Can I plug in 3? Can I get a 3 here? I don't know. Let's see. Okay, so let me erase this. Okay, so what happens if I try to plug in 3? Well, let's see. What am I going to get? What do I get if I plug in 3? It's just, I mean, it's going to be minus, it's going to be, okay, it's going to be minus 1 to the n over n plus 1 squared, yeah? That's like the alternating p-series, correct? And what's true about that? Converges, okay? So I can plug in 3. So what's the interval of convergence for this thing? Bracket 1, 3 bracket. Of course, the radius of convergence in this case was 1. The center for that thing was 2, yeah? Now, technically speaking, we had some terminology that we used for these things. We called series that were centered at things other than 0 Taylor series, yeah? Taylor series centered at particular numbers, like 2 in this case. If you have just powers of x, that's technically centered at 0. That's called a Maclaurin series, okay? Maclaurin series. Okay? All right. Any questions? Any questions on that? Yeah. Didn't we just do some natural log ones?
Like one that has like that one was kind of like the basic form of like this natural log of 1 plus x. Like how it said.
Yeah. All right. So, I mean, okay. You know, what would you do if you had something like, let's see. Oops. Okay, so you know this series right here. So logarithm of 1 plus x equals what? X minus x squared over 2 plus x cubed over 3 minus et cetera. And what's the interval of convergence for this thing? Well, okay, -1 to 1, I can actually plug 1 in because I get the alternating harmonic. But if I plug in -1, it diverges. It's actually the negative harmonic series. Okay. So I don't know. So like if I had the logarithm of 3 plus 4x, for instance, like we had on the test, I mean, there's a couple of ways we could proceed. But one that I didn't do yesterday necessarily is that you could factor out 3. You could write this as logarithm of 3 times 1 plus what? 4/3 x, okay? And then what you could do is you could say, well, I could use the law of logarithms and say that this is logarithm of 3 plus the logarithm of 1 plus 4/3 x, okay? And then what you do is you say, oh, well, for crying out loud, I know what logarithm of 1 plus x does. What you do is you kind of replace x by 4/3 x. Does that make sense? And up here, you know that you had convergence if -1 was less than x was less than or equal to 1. Here, x is being replaced by 4/3 x. Do you know what I'm saying? Yeah? Therefore, you're going to have convergence. So you're going to have convergence if -1 is less than 4/3 x is less than or equal to 1, which, by the way, tells you what? Where can x be? X can be between where and where? What's the largest x could be? 3/4. What's the smallest x could be? -3/4. Okay, so the interval of convergence for this thing that I'm about to construct automatically comes from that. It's -3/4 to 3/4. Yeah? And what is the radius of convergence for this thing? Before, we haven't even gotten the series yet, but what is the radius of convergence going to be? 3/4. The radius of convergence up here was, of course, 1. Okay, but we just replaced x with something different. Okay, so what is this series? Let's write it out. Okay, it's logarithm of 3, and then I just straight plug in. Right, this isn't going to be rocket science. All I'm going to do is straight up plug that in for x. Yes, in all of these terms. Okay, so it's going to be logarithm of 3. That's the constant, plus x, which is 4/3 x, minus 1/2 x squared. So it's going to be 4/3 x squared plus 1/3 x cubed. So this is going to be 4/3 x, all of this cubed, minus et cetera. Do you see it? And that's the Maclaurin series for this particular thing. Yeah? And we know what the interval of convergence is, and we know what the radius of convergence is automatically. Yeah? So you can kind of wrestle this function into a power series using the power series for logarithm of 1 plus x. Okay, so that's a good thing to know how to do. Okay? Other questions? Well, that's it.